The question here is convert to polar. Now, in order to understand what's going on, you should be able to draw this graph, right? So let's try to draw the graph to see what's going on. Okay, we're not so used to handling square roots, so let's square both sides and move everything to the left. You get x squared minus 4x plus y squared equal to 0. Okay. What is this?
It's a circle with the radius.
It looks like a circle. How would you definitely know it's a circle? By completing the square. How do you complete the square? Take half of this number, square it, and that's what? What number is that? Half of 4 is negative 2. Half of negative 4 is negative 2. Squaring that gives you positive 4. If you add 4 both sides, you get a complete square on the left, right? What is this? If you factor this, think about two numbers that add to negative 4 and multiply to 4. Negative 2 and negative 2, right? So it's x minus 2 times x minus 2, which is x minus 2 squared. Okay? So that's what you're getting. This really means this. And this means it's a circle of radius 2, centered at 2 comma 0, positive 2 comma 0. So this is a circle centered at 1, 2 steps right, 2 comma 0, and it's this circle. That's this equation. However, if you drew this, this will be slightly different. What's the difference between the graph of this and that?
Half a circle.
It'll be a half a circle. Why?
It can't be negative.
Because y cannot be negative. You're only going to get the positive one. Oh, you guys are geniuses. Nice. All right. So that's the graph. And then this is y equal to 0. Y equal to 0 is this thing. And you're trying to paint the region upwards, right? So we see what this means. It's trying to integrate this function over this domain, this half circle. Okay. All right, next thing. Okay, so we found out the domain. Usually when you want to convert one double integral to another double integral, you have to draw the domain, or else you don't know what you're doing. Okay. All right, so that'll be the first part. Now the second step is to change this into polar coordinates. How do you do that? Well, we have to figure out how to change this into polar. What do? X squared plus y squared should be replaced by r squared. And 4x should be replaced by 4 times r cosine theta equal to 0. And then since they have r as a common thing, so it's either r equal to 0 or r equals to 4 cosine theta for this to work. We know this is not right. R equal to 0 gives you the origin, right? So it must be r equals to 4 cosine theta. And we already learned that if you draw r equals to 8 times cosine theta or 8 times sine theta, it gives you a circle where it touches the origin, right? Because it's like a rose with one petal. I explained that rose with one petal is actually a circle. Remember that? Okay. So that's why this actually explained exactly this. Now we have to think about how to paint this region radially. Where do you begin?
2.
Where do you begin?
1.
What is this point?
0. No.
0. R equal
Well,
to
I
0.
can't
That's where you begin. Where do you end?
4. No.
4. No. Here. 4 cosine theta. 4 cosine theta. And then for theta, what's the minimum angle?
Zero.
0, and the maximum angle?
90.
Yes, start until you reach 90. There's always an overlap between the range that you draw to this domain, right? But right after 90 degrees, it no longer has any overlap. So 90 is the maximum. So it's from 0 to pi over 2. And then dy dx is now replaced by r dr d theta. I said that this is always true. Always dy dx should be replaced by r dr d theta. And then finally, x squared plus y squared should be replaced by r squared.
Wait, R squared just R.
No, r squared. R is equal to square root of x squared plus y squared. So if you want x squared plus y squared, you need r squared. So at the end of the day, you rewrite this as r cubed, and that's it. That's how you convert a rectangular coordinate double integral into hard coordinates.